Welcome to my today's video lecture on problems based on exponential Fourier series. It's me, Mohammad Imran sir, from EEE Department, MJCTE. Coming to this slide, we have a problem that says determine the exponential form of the Fourier series representation of the signal as shown below. The signal is like this. It is a triangular signal, repetitive triangular signal for equal interval of time. We can say that, and this is in symmetry and it is periodic signal. So for this periodic signal, it is to be noted that here it is minus t by 2 and here it is 0 and it is t by 2 plus t by 2. So for this we'll mark the coordinate as p, for O we'll mark it as q and this as r, so that it is for one complete triangle and one periodic cycle. So for this one periodic cycle we will be determining the value of signal, which is nothing but x of t. So x of t first we need to determine for one complete periodic cycle. Coming to evaluation of x of t, initially I would like to consider one periodic cycle of the triangular wave, that is like this, and for this we have got 0 here plus t by 2 and minus t by 2. So here I am marking this point as P, this point as Q and this point as R. So for the left side it is for the negative side of the signal and the right side is the positive side of the signal. First I will evaluate x of t for the negative side, then I will evaluate x of t for the positive side with the positive conditions, 0 and t by 2 for the positive conditions, negative side 0 and minus t by 2 for the with the negative conditions. So looking at the expression, we know that initially the straight line equation is y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. Also I am assuming that y of t is x of t and x is equals to t. So the points are P and Q are as discussed. Point P is nothing but here at this instant value of P is on x-axis is minus t by 2. There is no y-axis part, so it is 0. So first coordinate is minus t by 2 comma 0. Then this is 0. We have some value over here, that is a, 0 comma a. Not to forget that here the value is nothing but the amplitude is a of the signal, whereas here it is 0, here it is 0. So moving on with this, we have got q is equal to 0 comma a for this q, okay, and for r it is t by 2 comma 0. So we have got the coordinates. Then substituting p and q in the equation, straight line equation, we get this. On solving, I finally conclude that x of t is, conclude that for the negative side of the signal, x of t value is a plus 2a small t by capital T. Similarly, I am finding the value for positive side of the signal using q and r as the coordinates. This is for the positive side value of x of t. So moving on forward, I am using the same straight line formula but using the coordinates q and r which are on the positive side to evaluate the value of x of t. After simplifying, I finally arrive at a conclusion that x of t is a minus 2 small t a by capital T. So we can write it for one complete period is nothing but x of t for the negative side of the signal is a plus 2a t by t, and for the positive side it is a minus 2a t by t. So these are the limits which I am assigning. Instead of writing this t belongs to minus t by 2 to 0 and t belongs to 0 to plus t by 2, we can also write it in terms of its limits like this in this format. So this goes for this one actually, and this is for this one. I have written the other way around, so you please make a note of that. In order to evaluate the exponential Fourier series expansion, of the given problem, we need to find initially the value of C naught. That can be determined using the Fourier coefficient formula Cn, which is given as Cn is equal to 1 by t integral of minus t by 2 to t by 2 x of t, input of the signal, times exponential e power minus jn omega naught t into dt. So now substituting n is equal to 0 in the above expression, n is equal to 0, we get C naught, instead of n we are getting 0, C naught, and this exponential e power 0 becomes 1, and we are left with integral 1 by t minus t by 2 to plus t by 2 x of t dt. Also we know that value of the determined signal for the negative side and for the positive side is given by these equations. Now solving back the value of C naught, we get C naught is equals to 1 by t, integral is from minus t by 2 to 0 and from 0 to t by 2. So I am splitting the integral into two, 1 minus t by 2 to 0, another integral from 0 to t by 2. So from minus t by 2 to 0, we know the value of x of t, that is this much, and for the positive side we know the value is this much. Now I am integrating for these to evaluate the value of C naught. Finally the C naught value is evaluated as C naught is equal to a by 2. Now I am evaluating the value of actual Cn coefficient of the Fourier series expansion. So the Cn formula, we know that it is given by this expression as shown previously, and also within the limits the x of t value gets changed. We know that the value of x of t in this case with respect to different limits we have different value of x of t, so that is being substituted over here in the integral to be evaluated for n. Moving on forward, the integral is being applied, common terms are taken out, a is common here, a is taken out, and integral by part is applied to all the terms. So we have got 4 such integrals in total to be evaluated. Finally, the integral over exponential gives me the same exponential divided by the extra terms within the limits, upper limit and the lower limit. The final computation results in Cn is equals to a divided by n square times pi square minus a e power jn pi by 2n square pi square minus a e power minus jn pi by 2n square pi square. When this n is even, this exponential value is 1. As a result, value of Cn is 0. We can justify this claim initially by substituting the value wherever it is, this value in this expression as 1, everywhere as 1, wherever it is. Minus means 1 by 1 is again 1. Okay, so this 2 half and half becomes 1, negative 1, and this is positive 1. So negative 1 and positive 1 gets cancelled if n is nothing but, in this case this Cn is 0. If n is n, and in this case Cn is 0 if e power jn pi is 1. Similarly, if n is odd, then e power jn pi is minus 1. So it is assumed as e power minus jn pi is minus 1 if n is odd. So the value of Cn in this case would become 2 times a by n square pi square. So this is what we can tabulate for when n is odd. We can say that when n is odd. Finally, we need to determine the expression, exponential Fourier series expression. The exponential Fourier series expression x of t is equals to, it consists of the odd part 0 and even part of the signal. In other words, the negative side 0 and the positive side. I would better say that odd, 0 and even part. And already we know that the value, this C naught value, I think we already got it as a by 2, which we have determined previously. Okay, let us look at the next part of the expression. And we also know that the value of even part was 0. We have determined the value of Cn for n is even is 0. So automatically this component gets 0. So we are left with nothing but the odd part and the 0, negative part and the 0 part. So negative part means it has got the, in this only the even part of the Cn is 0, even part is 0, but there exists the odd part. So that means odd part of the positive side still exists, and this side it is the negative side. So include, that means this is the negative odd and this is the positive odd. So that means the series becomes plus or minus odd components of this plus C naught. So further expansion of sigma into individual terms gives me 5, 3, minus 5, minus 3, minus 1, 0, then 1, 3, 5. Remember, we have got the C naught value already there, already present from the previous step. So C naught remains as it is. Left side is the negative odd numbers, right side is the positive odd numbers. Then the value can be further evaluated as, we know that the value of Cn is already 2a by n square into pi square. So in this case the value of C minus 5 would be 2a by minus 5 whole square into pi square, that is 2a by 5 square pi square. Similarly C minus 3 would be 2a by minus 3 whole square into pi square, that is 2a by 3 square pi square, and so on. It goes on for all the different values. So similarly this side it goes for this C1, positive C1, positive C3, positive C5, so on and so forth, and the series, because it's an expression, Fourier series expression, the series continues. And finally we can take common 2a by pi square and can write the series in this form. Okay. Just a quick overview of what we have done. Initially we have determined, identified the value of x of t, it is periodic, and for one periodic signal or one periodic cycle we have determined the value for negative side of the signal and positive side of the signal. We have evaluated the value of C naught, then we have evaluated the coefficient Cn, then we have used the value of Cn for getting the expression. For even and odd we have determined the value of Cn and we have determined the Fourier series expression. Finally, do not forget to share, like and subscribe. It's me, Signals to Scope with Imran. Thank you.